Hello and welcome to this MATLAB simulation. My name is Sumit Kumar Chaubey, and in today's session we are going to discuss simulation of BCH code in MATLAB. Okay, but before we start simulation of BCH code, let's quickly review the description of the BCH code so that it will be fresh in our mind, so that when I go through this simulation it will be much easier for you to understand it. Okay. In this simulation, we are actually going to simulate a narrow sense binary BCH code, which is also called primitive BCH code. And the description of BCH code is like this, that for any positive integer m greater than equal to 3 and t less than equal to 2 to the power m minus 1, there exists a binary BCH code with the following parameter, that block length of the BCH code is actually equal to n equal to 2 to the power m minus 1. Number of parity check bits n minus k is less than equal to mt, and minimum distance d minimum is greater than equal to 2t plus 1, where t is our error correcting capability. So this d minimum is actually theoretical minimum distance. Generally it is greater than this value 2t plus 1. Okay. So let's start with the MATLAB code now. Okay, so we are going to start the simulation with the clean slate. It means we are going to clear all the variables that are there in the workspace. For example, you can see here in the workspace that I have already run this code one or few times. So you can see there are certain variables here. So I will have to clear these variables and I will close all the windows. For that there is command close all, and then CLC. This is basically to clear the console or command window which is here. Okay, so we are going to start it, and to run it I'm going to run an advance to the next section. Now you can see all the variables in the workspace are clear and there is nothing in our command window. So we are basically starting with a clean slate. Now as we have seen that our input parameter is n and k. Okay, so our n here is basically going to be a length 2 to the power m minus 1, where m is greater than equal to 3. It means it can be our either 7, 15 and so on, for all the way up to 256 or something like that. Okay, so first we are going to ask user to give us this input. So for that we are also going to run an advance, and we will ask user to provide us a input for the code word length. Okay, so code word length is going to be, let me give it 15, right? So this is going to be 15 now, and I'm going to again start with next iteration. So here we are going to for this particular n, we are going to actually display all the possible message length and error correcting capability. Okay, so for this n, there can be multiple message length for different error correcting capability. Okay, so we are going to display that. So in the first column we are going to display code word length, in the second column we are going to display message length, in the third column we are going to display the corresponding error correcting capability. Okay, and to do that, the code, the function is BCH NUMERR. So it is basically going to give us BCH numer is going to give us code word length, message length and error correcting capability. Okay, and then here you can see that we are selecting the message length separately because we are going to use it further. Okay, so now I'm going to run this section and advance into the next section, and as you can see here now we have this t, and as you can see that n here is 15 in all three cases, and here our message length is 11, then our error correcting capability is 1. Here our message length is 15, then our error correcting capability is 2, and message length is actually 7. This is the code word length, and then error correcting capability is 2, message length is 5, and our error correcting capability is 3. So based on this, we can select any one of these codes and we can implement that code, okay, in the MATLAB. So let's begin to the next section. Now we are going to generate generator polynomial error correcting capability for each and every code word, okay, for each and every possible code word that can be there, okay. So we are not going to consider a particular message length, but what we are going to do is that we are going to display, we have seen that we already have 3 types of BCH code here for n is equal to 15, and now we are going to implement, we are going to display the BCH generator polynomial for each and every one of them. So I'm again going to run an advance, and you can see that here is going to be our generator polynomial. So here is the generator polynomial for error correcting capability 1 and message length 11. Here is our error correcting capability 2 and message length 7. Here is message length 5 and error correcting capability 3. So these are the 3 generator polynomial for that, okay. Now we are again going to move to the next section, and in this section we are actually going to ask user to provide us with the message length, what message length he wants to implement, okay. So our message length, we are going to ask user for the message length, and based on that message length we are going to generate a BCH generator polynomial, which you have already seen is kind of LCM of minimal polynomial that we have already discussed. So this BCH gen poly actually generates the BCH generator polynomial based on n and k. We have to provide them with n and k, message length and code word length, and it is going to give us generator polynomial g and error correcting capability t. So it's going to return an array there. Then we are going to ask user to input the message or the message that the user want to encode, and we know that the message length is k here. We have already asked user for that. So based on that, we are going to initialize our message vector with zeros of 1 and k, and then we will ask user to actually provide us with the input one by one, okay. And then finally I'm going to convert my message vector, which is basically an array, integer array, to this Galvez field, okay, because this algebra is in Galvez field, so we have to convert it into Galvez field, otherwise it will be unable to implement that, okay. So let's run this section now. So we are going to run this section, and this will ask us to provide us with the message length. Here you can see the message length, let me select it to be 5 only, okay, and message length is 5. And based on that message length, you can see that for that we have this generator polynomial message length 5. So here we have entered our message length, which is 5, and then generator polynomial g is basically this is our generator polynomial, and the length of generator polynomial is actually equal to 11. You can see 3 3 and then 3 and 2, 11, and t is equal to 3. Now we have been asked to enter the message that actually we want to encode, and we are going to start with that. So this is 1, and then again 1. Let me write 0, and then again 0, and then 1. This is the message 11001 that we want to encode, okay. So now we are going to run to the next section. So in the next section we are actually going to encode our code word. So for that the MATLAB function is BCH encode, and the parameter that it takes is m, which is the message, n, which is the code word length, and k, which is the length of the message. And then we have to provide an optional parameter whether we want to append our parity bits in the end or in the beginning. So this is basically the position, this is for the position of the parity bits. So we have given here end, you can also provide it with the input beginning if you want your code, your parity bits in the beginnings. Okay, so we are going to run that. This is the way we are going to encode. And actually we are going to, before decoding our code word, what we are going to do is that we are going to produce a nice noise, and we are going to add that noise, and based on that noisy code we are going to decode the noisy code. Okay, and in this way we will be able to check what is the error correcting capability of our BCH code. Okay, so we know that our error correcting capability is 3. So this is rand error is basically provides us an array of 1 to n, and the error correcting capability is t equal to 3. So in the 3 position it is going to provide 1. We have already seen that. This is how our noise is going to look like. And then our noisy code word C noisy is equal to CC code word, which is the original code word that we have encoded, plus the noise, and this is our noisy code word. And then we are going to decode using BCH decode. So this is going to take the noisy code word n and k. Okay, and here it is going to give us DC decoded code word, n error number of errors, and CC. Okay, so this is going to give us all these 3 value: code word, error, as well as decoded code word. Okay, so now we are going to run this section, and you can see here that once we run this code word, actually it's going to be a bit screen is a bit small here. So you can see that here is our message, and our original code word is this. This is our original code word, and this is the noise. As we have seen that our error correcting capability was 3. So in the 3 position it is actually given 1, and rest of the position are 0. Okay, so we are now going to add this noisy with this code word, and those positions, for example, you can see that 5th position has been changed. 5th position was 1 here, it has been changed to 0. So similarly all these other positions are also going to be changed. Okay, and this is going to be our noisy code. And then after that we have decoded our code word, and decoded code word is 11001, and this is actually the message that we have given. And number of errors, it is saying that there were 3 errors, 3 positions error were there, which it has actually calculated and which it has actually corrected. And then we have the corrected code word, which is like this. It has given us our original code word. Okay, so this is how one has to implement the BCH encoding and decoding process in the MATLAB. You can see it's a very straightforward code word. There is nothing much. Our input parameter is basically the number of code word length, basically the code word length, and the message length, and the message itself. Okay, so these are the 3 parameters that we are asking user for the input. And then we have 3 functions, 3 or 4 function actually. Then the very first function that we have used is BCH numer. It basically gives us the code word length, message length, and error correcting capability. BCH gen poly is basically used to generate the generator polynomial for the BCH code, and BCH encode is the code is used for encoding the message code word into the code word. And then we have rand error, which is basically going to randomly generate t errors, and our BCH decode is the function using which we are decoding this this noisy code actually. Okay, so with this I would like to conclude this session. I hope that it has been useful. Thank you. I will see you in the next one.